I suppose you see whiteboard, right? Okay, the topic that we are discussing now is called mathematical induction. A mathematical induction is one fantastic way to prove something in mathematics, to prove formulas, to prove, see some formula that we're discussing, yeah, you accept with me, and you don't see where I come from this, professor. Is mathematical induction. Okay, mathematical induction. Let me explain one motivation example, and after I want to explain the theoretical part behind mathematical induction. And after, finally, we are doing several examples of the mathematical induction. Okay, the motivation example is, suppose I need to see, suppose n equal 1. N equal 1. And you have 1. It's a value associated with the n equal 1. Suppose n equal 2. And so you adding 1 plus 3. So what is the idea? The idea is adding the odd numbers, the two first odd numbers, because n equal 1 is 1. The first odd number is odd numbers. You adding odd numbers, the two first odd numbers. The answer is 4, no? And n equal 3 is 1 plus 3 plus 5, ¿no? Que es 9, ¿no? Wow, entonces I saw some pattern, some regularity, que es 1 square, 2 square, 3 square. Let me continue at least one more. 2 more. Suppose 4. The first 4 is 1 plus 3 plus 5 plus 7. This is 4, 9, 16, que es 4 square. One more, because I want to make sure. It's 1 plus 3 plus 5 plus 7 plus 9. Es 16 plus 9 que es 25. And 25 is 5 square. Entonces, okay. Entonces, I need to prove the thing I try to see is que for any m, the formula is 1 plus 3 plus 5 plus 7 plus 9 plus to m all number, the answer is n squared. So I need to prove, actually it's no m, sino 2m minus 1. O sea, the a sub m que corresponde with the sequence of the odd number is 2m minus 1. Let me try. Suppose n equal 1 is 2 minus 1 is 1. Suppose n equal 2, 2 times 2 is 4, minus 1 is 3. And actually the a sub m term is no m, is 2m minus 1 plus 2n minus 1. Erase. Equal to n squared. This is the way I need to prove using mathematical induction. The word induction indicates us like a detective, you know? So in the detective, Sherlock Holmes, you get different clues. And one particular example, the collection of the one particular example, give me the conclusion. I discovered who is the killer, right? Sherlock Holmes. And this is the induction. You know the result of the particular example 1, 2, 3. But who guarantee you that for any number, natural number, of course, 1, 2, 3, 4, 5, 6, 7, 8, the formula is valid or invalid? This is the idea behind mathematical induction. Do you understand the idea? Do you understand the idea? Do you understand the idea? Answer me.
Yes.
Yes.
Who said yeah? Matilde, no? Moyo.
Yes, it was me.
Yeah, I know. Always you are. Pay attention and answer me. Okay, Matilde, then to apply the mathematical induction principle, mathematical induction principle, mathematical induction M principle, we have two steps. The first step is called base step because it's the first, it's super easy. And you prove somehow that x1 is true. What means x1? It's a statement. Statement 1, que in this motivation example, remember, statement 1 was at n equal 1. It's true because 1 is equal 1. So 1 is equal 1 squared. Sometimes happen, not always the statement 1 is true. Maybe statement 1 is false. Statement 2 maybe is false. And statement 3, so when you talk about 1, 2, 3 is n equal 1, it's true. And continue true and 4 and so on. So no, don't expect, in the majority of the scenario, yes, the base step corresponding with n equal 1, but not always happen. It's the thing I try to explain. You see in the example. Okay, now the most important is the second step, okay, by the way, is the last one, is the inductive step. Inductive step. Let me explain a little. Inductive step, you assume that A sub k is true. Now who is k? Well, k is a number between 1, no equal. Between 1 and m. Suppose que I did here to n equal 5, you assume arbitrary, but you assume k, not for a specific number, no. You assume that this is true. This is very important. Under this assumption is true, you will be able to prove, so to show, so you will be able to prove that A sub k is true. And another condition I need to prove is that A sub k is true, assume is true, imply that A sub k plus 1, this statement is true also. So this is true and this is also true. But let me enclose. Okay, this is, look, this is true also. Okay, repetition. You assume that S sub k is totally arbitrary in the middle. It's true. And that means that the next one, because k plus 1 is the next, is true, imply que es true. That means that A sub k plus 1 is also true. So one visual interpretation of this is, suppose, you know, this is the piece of domino. This is the piece 1, this is the piece 2, bam, 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 bam. Entonces I assume one piece k. That's true. And true means que when I push in 4, the next one is k plus 1. That means que si this fall and touch this, fall this. And this motion continue forever for any value of the k. K plus 2, k plus 3, and so on. Okay, so the only thing you need to prove, you assume this. See, when you assume this, you For other hams, another manipulation, you prove that this implies that the next is true. So this implies this is true. To be true is que fall here, and it's fall again. So now you prove for any. So you don't need to do for infinity case. No. Because the natural number is a well-ordered set. And continue. Suppose you assume that k is 20, and you prove somehow that 20 implies that 21 fell also. So 22, 23 fell. This is the idea. So now the conclusion of this is a sub k is true also, and we come back at the beginning. It's cyclical idea. Okay, do you understand? A little bit confusing, I know. This is to understand 100%. You need to take one course of the mathematical logic. But this is the idea for the induction. And some people explain not too deep in details, explain. You assume this, you will be able to find that the next is true. So say this continue forever. Okay, let's apply. So you understand this. Let's go directly to the motivation example, and you apply now formally that principle, mathematical induction. Okay, you start for A1, okay, the base step. Well, in this case, n equal 1. Well, n equal 1. The formula I need to prove is u squared. So n squared is equal 1. And plugging in is 1 squared. So 1 is equal 1 squared. This is true. This is true. And end the story. We did that part. Now you assume that a sub k is true. How we assume that? Well, you take the same formula that you want to prove and replace n for k. Entonces I assume que 1 plus 3 plus 5 plus plus 2k minus 1 is equal k squared. You assume that this is true. I did at least that part. I need to prove that si this is true, imply that a sub k plus 1 and a sub k plus 1. How do you find a sub k plus 1? Well, let's do it. 1 plus 3 plus 5 plus . And we have plus 2k minus 1 plus you have another guy que es 2 or 2k plus 1 minus 1. So you include another term. This is the term corresponding with the k. And this is the k corresponding with the k plus 1. It's the same formula, but you replace k for k plus 1, no? Do you follow me? Do you follow me? This is in the left-hand side. In the right-hand side, no. In the right-hand side is k plus 1 squared. K plus 1 squared. Okay, let me try. So we have 1 plus 3 plus 5 plus. This is 2k minus 1. Okay, this is the statement for the k, no? And the k plus 1 is, this is distributed now, algebra, some algebra you need to apply. It's 2k plus 2 minus 1. Okay, actually it's 2k plus 1. Okay. Or leave like that, either way. Is 2 times k k plus 1 minus 1. Okay. Should be equal this. And so I propose you expand this. This is square the first, plus twice multiplication both, plus square the second. Now, the thing I assume gets true is this part. This part, okay, by the way, is equal, that part is k squared. This is assumption. Plus, I distribute it now. This is the moment to distribute it. 2k plus 2 minus 1 should be equal k squared plus 2k plus 1. One more time, we combine like term. 2 minus 1 is 1. And this is equal to proof. Using mathematical induction. Any question? It's easy or complicated? What's weird? Maybe sometimes it's long process. Of course, I select the motivation example that's easier. Any question, guys? Do you follow me? Totally lost? You don't understand anything?
Yeah, problem.
Okay. Okay, one more example. This was motivation example. Now I am doing now a real example. Okay. Suppose this example that you know very well when you study summation notation. A 1 plus 2 plus 3 plus plus m is equal n plus 1 divided by 2. Do you remember this example? Okay, the sum, suppose I apply summation notation, the sum for k equal 1 to m of the k is equal n plus 1 divided by 2. Remember that I explained this, I don't explain where I come from this, no? Because this is a moment to prove that. This is summation notation. This is the expand summation notation, and it's equal to that formula. So basically, I am using now the summation, the mathematical induction to prove this formula, that formula. Okay? Okay, is equivalent to the summation of the first natural number. Okay, let's do it. X1, always remember 2 steps. Basic step S1. If it doesn't work with the S1, you try S2, S3 until you get through. And after you assume S sub k and continue the process. Well, S1 is normally for n equal 1. It implies n equal 1. And n equal 1, obviously, you take the first guy, get this. And substitution 1 m is 1 times 1 plus 1 divided by 2. Es obvio que 1 plus 1 is 2, 2 divided by 2 is 1, times 1 is 1. It's true. It's true. Super. Now, in the inductive step, you assume that A sub k is true. Who is A sub k? Well, I copy the same formula. I don't change anything except the variable. Okay, now it's k. You suppose that k is smaller than m. It's intermediate. So under the supposition that this is true, this is supposition, I want to prove, remember, S sub k is true, assumption. See, I will be able to prove that S sub k imply that S sub k plus 1 entire statement is true. Okay, this is synonymous to say, see, one piece fell, the next fell also, that indicate S sub k plus 1 is true. And this process continues forever for any real number. Okay, now, so I take a sub k plus 1. Okay, I have no idea if it's true or no. Yeah, I copy 1 plus 2 plus 3 plus plus k. I copy exactly the same, but I include extra que es k plus 1. Because you suppose one more. And you replace in the right hand side k plus 1. Entonces k plus 1 times k plus 2, no? Because actually it's k plus 1 plus 1, no? So you replace k for k plus 1. And with extra 1, 1 plus 1 is 2 divided by 2. Makes sense, right? However, I suppose that this part is k plus 1 divided by 2 plus k plus 1 should be equal k plus 1, k plus 2 over 2. And the rest is algebra. See, this equation is identity. We finish. Okay, the least common denominator is 2. Because we have k plus 1 plus 2 times k plus 1. Now you factorization k plus 1. You see here and here the same factor. And we have k plus 2 divided by 2. And you see, wow, it's the same. Proof. The formula is correct. More clear now? More clear now? Yes or no? Tell me, guys.
Yes.
Okay. Erase or no?
Yeah.
Mm-hmm. Suppose I need to prove that formula. This is the formula that we studied in the summation part. Pero let me translate this to the more clear language. No? This is k equal 1. This is 1 square, no? Plus 2 square plus 3 square plus 2 m square is equal m plus 1 2m plus 1 divided by 6. I using at the beginning the summation notation, but no, more clear, and that part expand summation notation. Okay, let me try mathematical induction. X1 means n equal 1, and 1 is the first guy, get 1. Okay, 1 squared get 1. However, in the right hand side, plugging in 1 plus 1, 2 times 1 plus 1 divided by 6. Okay, we have 1 times 2 times 3 over 6. Oh, it's 6 equals 6 divided by 6. It's true. X1 is true. I suppose that always we get true, no? Because, well, I don't know. Depends. You want to prove one formula that nobody are doing before, maybe, of course, you get the conclusion that no, the formula doesn't work. See, at least one statement says it's false. Well, no. The first one must be false, but now after the domino piece continues forever, yeah. Okay, entonces assume you assume it's okay. It's true. That means que 1 squared plus 2 squared plus 3 squared plus plus k squared is equal k plus 1 to k plus 1 over 6. Okay. Now I try to investigate the next one, que es x sub k plus 1. I have no idea. Entonces I put 1 square plus 2 square plus 3 square plus plus k square plus k plus 1 square is equal. And you replace k for k plus 1 in the right hand side. Entonces it's easy, that part is k plus 1 is k plus 2, makes sense because it's k plus 1 plus 1. But this is not easy. It's 2k plus 1. When you replace here 2k plus 1 plus 1. Entonces 2k plus 2 plus 1 is 2k plus 3. Do you follow me? 2k plus 3 over 6. Good? Do you understand what it's doing? Do you understand where I come from? 2k plus 3?
Yeah.
Uh-huh. Now the assumption was this guy is equal k plus 1, 2k plus 1 divided by 6. Now ready. 2. Combine later. Okay, at least common denominator is obvious que 6. So I'm working in the left hand side, guys. Forget about the right hand side. Maybe in one moment I need to manipulate. Oh no. Entonces k plus 1, 2k plus 1. And we have here plus 6 times k plus 1 square, no? K plus 1 square. Okay. So now I see que k plus 1 is a common factor. I factor out k plus 1. This is algebra. And we have k times 2k plus 1 plus 6 times k plus 1 divided by 6. Okay. Now distribute the property is 2k squared multiplication plus 2k plus 6k plus 6 divided by 6. Now ready to combine later. Is k plus 1, 2k squared plus 7. This is, sorry, I make a mistake here. This is 1. Let's solve the 1, right? Because k times 2k is 2k squared. And k times 1 is k. This is 7k plus 6 divided by 6. You can continue, you can if you want, pero no. I suppose que it's much better manipulation the right hand side until you get identity equation or no. So in the right hand side, I propose you FOIL this guy. You FOIL. So I have x plus 1, and multiplication is 2k squared plus 3k plus 4k plus 6 divided by 6. And now we combine later. X plus 1, 2k squared plus 7k plus 6 divided by 6. Wow. In that moment, I can see Okay, these expressions are the same. Proof. Do you see or no? Sometimes it's long, the proof, but it's just algebra, but elementary algebra. Clear or confusing? Let's do one more example. Let me know, guys, if you follow me or not. In the test, we have one problem on the mathematical induction. In the review package, of course, we touch again. We go over again to the mathematical induction. Okay, one more. Suppose this example is given also in the lecture of the function summation notation. No? Yes, when you have summation from K1 to M of the K cubic, and the answer is n plus 1 divided by 2 squared. This is the formula. Okay, I give you one moment, and you never say, well, professor, where I come from this? Okay, so now, this is equivalent to say n squared, n plus 1 squared, divided by 4, no? Square everything. Okay, let's start mathematical induction. Statement 1, que is at n equal 1. Well, the first guy in this summation is 1 cubic. And 1 cubic should be equal to the result of that formula. The result of that formula is 1 squared times 1 plus 1 squared divided by 4. 1 squared is 1, 1 plus 1 is 2, 2 squared is 4, divided by 4, 4 divided by 4 is 1. True. Good, very good. And you assume S sub k true. And S sub k is, let me try. Let me expand the summation. Entonces es 1 cubic plus 2 cubic plus 3 cubic plus 2 plus k cubic should be equal k squared, k plus 1 squared divided by 4. This is assumption. I suppose it's true. Now S sub k plus 1 is the next. I have no idea. But you include 1 cubic plus 2 cubic plus 3 cubic plus k cubic plus k plus 1 cubic should be equal k plus 1 squared, because you replace in the right hand side k for k plus 1. K plus 2 squared divided by 4. This is the idea. And you suppose that is true. Therefore, you replace this part by k squared, k plus 1 squared over 4 plus k plus 1 cubic equal something that I don't want to copy again. And you try to manipulate this. The least common denominator is 4. K squared, k plus 1 squared, plus 4 times k plus 1 cubic. Yeah, I can see, wow, K plus 1 is the greater common factor, greater common factor, es obvio que es K plus 1 square. This guy. Ya he factorado. K plus 1 square. And stay inside the parenthesis or bracket, whatever you want. You have K squared plus 4 times K plus 1 squared. Because I factor out. No, wrong. You factor out 2. It's 3, stay 1. But don't forget the parenthesis, no? Because 4 multiply everything. Divided by 4. Okay, super. Now. Distribute the property. K plus 1 squared is K squared plus 4x plus 4. Over 2. Okay. We almost finished. Now, either way, guys, there are no one unique way to do this. You're using your imagination, your common sense, you FOIL, a factorization. In this case, I don't know. For me, it's easier, the factorization this, because I can see that this trinomial is perfect square. And the factorization is K plus 1 squared is open 2 parentheses, no? It's K, 2, no? 2, plus. Wow. But this guy are twin brother, no? Sorry, I copied 2, is not 2, it's 4. It's a 4, and it's a 4. So this is twin brothers. This is twin brothers. So it's K plus 1 squared is K plus 2 squared. It's the same. Divided by 4. And by the way, it's exactly the same, the answer we have in the right hand side. I don't need to manipulate the right hand side directly in this case. I don't know why. I get directly this answer. Fantástico, ¿no? Okay. I have another example. Let me try another example. Does that part look like easy or complicated? Or weird? What is the adjective for that part? Complicated, weird, confusing, clear, super clear.
It's clear.
One more example. Okay. Suppose this. Prove somehow. Okay, estas fórmulas que using induction, you suppose que it's true because following sound regularly. But I'm not sure. So to prove that I'm using mathematical induction. Suppose this. Wow, I have no idea. Suppose, well, okay, it's obvious. Let me erase that part. Look, suppose que this guy is, next one is 4 to the cube, no? And so 4 to the 4. And this is 4 to the n minus 1 because for n equal 1, 1 minus 1 is 0. So actually it's 4 to the 0, no? This is 1. For n equal 1, 2, sorry, is 2 minus 1 is 4, and so on. 3 minus 1 is 2 squared. Actually, my original problem is here. Not necessarily this is exponent and this is 1. Make sense? And this is sec is equal 4 to the n minus 1 divided by 3. Wow. Okay, it's doing. Mathematical induction, I make a decision. X1 is when the n is 1. And n1 is the first one. The first guy. This one, not necessarily is equal to this. No, dependent. It's equal to this. 4 to the 1 minus 1 divided by 3. It's all because true, because 4 minus 1 is 3, 3 divided by 3, and 1. The base step, this is the base step, is true. So I assume que K is also true. 1 plus 4 squared plus 4 cubic, too much. The only thing you should do is replace n for K. Because I assume que K is intermediate value. 4 to the K minus 1 divided by 3. I assume that this is true. This statement is true. Symbolic is in that way. Practical is in that way. See, I will be able to prove that this implies that the next is true. This continues forever like a piece of domino. Okay, so what are the x k plus 1? Well, 1 plus 4 squared plus 4 cubic plus. I recommend you copy this exactly the same because it's important to understand this. And you copy the next. No equal. The next. Include next. What is the next? Well, the next is 4 to the k. I guess so. Because this is for k plus 1. This is also for k. Is, see, the a sub m term is 4 to the n minus 1. And for the n plus 1, it's obvious that 4 to the n plus 1 minus 1. The 1 is cancelled, 4 to the, okay, or 4 to the k. Is equal, so you replace now 4 k plus 1, exponent minus 1 over 3. Okay, super. Super, and remember the assumption at the beginning was, okay, that part is equal 4 to the k minus 1 over 3. Plus 4 to the k should be 4 to the k plus 1 minus 1 over 3. Okay, always we end it similar. You condensing this and one common denominator gets 3. 3 times 4 to the k. This is multiplication. Equal. Okay. Okay. You combine like that. Who is like? This and this are like. Because it's the same term, but it's 1 here. And 1 plus 3 is 4. Actually, this is 4 times 4 to the k minus 1 divided by 2. Okay. Now, doesn't matter. So you break it down this or you condensing this and this. So I don't touch the right hand side. No, you touch it if you want. You multiply this. This is exponent is 1. Obviously, it's 4 to the k plus 1 minus 1 over 3. Okay, the same thing as this. Okay, I promise. Okay, in the review package, we see more examples, but it's the same thing. Let me try to present the last topic, empiric calculus. We almost the The semester is over, but I want to explain in detail. I want to explain in detail. Clear the mathematical induction? Yes or no? Let me explain in detail binomial theorem. This is important, guys, in calculus. Newton discovered the formula for the binomial theorem when he was 22 years old. You know, Newton is a genius, right? Let me try to prove that formula. Not necessarily using mathematical induction. Using intuition, and we can prove using mathematical induction, but it's too complicated. What is the idea behind this? So that you have a plus b, a binomial, to the n power. And this is equivalent, guys, to summation from k0 to m of the one thing that you don't understand now, but I want to explain in your moment. This is combinatory number a minus k times bk. This is the formula that Newton discovered. But how Newton discovered this? Is induction. Let's do it for k equal 1, 2, 3, 4, 5, and so on, and try to find the regular of this. Suppose a plus b to the 0 power. A1. Any expression or number raised to the 0 power is 1. And this one I want to copy here. 1. This is for associated with the m0. Now a plus b to the first power is just a plus b. Okay, it's easy. Now I copy here the coefficient c. Okay, by the way, this coefficient is 1, 1. I copy here 1 and 1, and this is for m equal 1. Okay, let's continue. A plus b a squared. Oh, I know very well this. This is a squared plus 2ab plus b squared. I copy the coefficients. The coefficient is 1, 2, and 1. This is for m equal to. Do you follow me? Do you follow me?
Yeah, I follow.
Yeah, I follow.
Now, suppose a plus b cubic. Oh, this is a little bit more complicated because you FOIL it 2 times, right? You multiply. Suppose that I'm doing using the long way. Wow, the long way is you multiply this guy. Let's do it here separately. A squared plus 2 times ab plus b squared. That was the multiplication, the 2 first. Actually multiply a plus b times a plus b times a plus b, no? 3 times. But I did the upper part, is this. A multiplication by a plus b again, and you FOIL. But in this FOIL we have 6 terms. But it's okay, it's unimportant. It's a cubic plus ab plus this, and this is 2a squared b, and this is 2ab squared, and this is ab squared plus b cubic. You see the multiplication? How many combinations? We have 3 here. 3 is trinomial and binomial. 3 times 2, 6. 1, 2, 3, 4, 5, and 6. And of course we can combine like term. X cubic plus 3 times ab. Look, this guy and this guy. But I make a mistake somehow. Is this time this is a squared, right? Ajá, entonces 3 times a square b. Ajá, guess you know is a square b, is this plus this together, no? 1 plus 2 plus 3 again. This and this gets lighter, is ab squared plus bq. Okay, I promise I guess the last time I can do it this by hand because I discovered the formula. Now exactly Newton predict. Okay, so now erase that part, stupid long way, and the answer is a cubic plus 3 times a square b plus 3 times ab squared plus b cubic. I copied the coefficients again here. Look. I copied the coefficients. The coefficients are 1, 3, 3, and 1. Do you see? This is for n equal 3. Suppose I need to do a plus b to the 4 power. It's too long process doing the multiplication. No. I can predict. I can predict. Exactly like a Newton say. Do you know this triangle gets formed? This triangle? This is called Pascal. Pascal triangle. It's famous in mathematics. And you see the property for the Pascal. Where I come from? That too. Where I come from? Well, let me try here. Let me write Pascal here. 1, 1, 1. 1, 2, 1. Where I come from this? Oh, no, I can't believe that these two come from addition 1 plus 1. And these 3 come from addition 1 plus 3. 3. Entonces now Pascal, this part is 1 always. And the number in the inside the triangle is formed by addition this. We can predict next column get 1, is 4, is 6, is 4, and 1. Yes or no? So at least I determine what the rule. I don't know if it's working forever or no. If you want to investigate this, you apply mathematical induction, but it's too long process. You trust to me, Newton do. This is 1, this is 6, this is 4, sorry. This is 4. This is 6, this is 4 again, and this is 1. This is for n equal 4. Okay. How many terms and what is the exponent? One of the, how many is, suppose see in 1 you have 2 binomial, in 2 we have 3 trinomial, in 3 we have 4. I suppose in 4 we have 5. And according to the Newton formula, look at that. The summation notation go from 0 to m. So from 0 to m, we have m plus 1. Okay, so you count 0, 1, 2, down to m. How many terms we have? M plus 1, including n and 0, x plus 1. That is a reason for n equal 3 we have 4, and for n equal 4 we expect to have 5, guys. And the first one, let me try here, is a to the 4 power. And the last one is b to the 4. I am sure, because this is a regular. Look, a squared, b squared, a cubic, b cubic, and we have 3 more, guys. No, because in total we have 5, and 3 more is this, and this. It says plus 4 is the coefficient c. A, you decreasing the a cubic power, and b to the 1 power, okay, it's invisible, right? And what is the next? The next is 6. A squared decreasing. In the formula for Newton decreasing, k is k from 0 to m. Entonces decreasing, this is going down, and it's increasing. This is 1 b squared plus 4. Now increasing, a to the 4, a to the 4, to the 4, no, to the third. And b to the third. No. Decreasing, coño. This is 8. 2 minus 1 is 1. And increasing is 3. Plus. Before. Wow, how many? 1, 2, 3, 4, 5. Nice. And you see how the exponent of the first guy, que say, pero in the example I put another letter, I put another number. No, this is theoretical part. We are discussing theoretical part. Now you see how the exponent of the A decreasing. 3, 2, 1, 0. No A. Okay, the sequence is, look, the first exponent of the A is 4, the second was 3, the second was 2, the second was 1, the second is 0. And it's obeyed to the formula, A minus K. And K starting 0, look, to N. However, the B exponent is K. Is B0, B1, B2, B3, B4. Super! I almost discovered the formula for the Newton. Okay, let's try now. A plus B to the 5th power, but without multiplication. No, hello. This is crazy. No multiplication. Is, first of all, I go back to the Newton, do the Pascal, sorry, triangle, to determine the coefficients, no? The Pascal continue forever in that direction. The next column, this is the column for the 0, this is the column for the 1. This is the column for the 2, this is the column for the 3, this is the column for the 4. Now the column for the 5. It's 1, 1. I know that. And this is 5, and this is 10, and this is 10 also. And this is 5. Okay, this is the coefficients. But for sure, this term, we have 6 terms, A to the 5th power, and the last one is B to the 5th. And the coefficients are plus 5, A to the 4, you decreasing, B to the 1, plus 10, A to the 3rd, B to the 2nd, plus 10 again, A to the 2nd, B to the 3rd, plus 5, A to the 1, B to the 4, plus B to the 5th power. Do you understand the idea? But so far it's too tedious doing that way. At least we simplify something, but not too much. Because I need to discover what is the mathematical rule of that number. And this is the combinatory number, NK. Combinatory number. And the formula for the combinatory number is the same formula that we use in probability, in statistics. Is n factorial divided by k factorial, n minus k factorial. And let me refresh your memory about factorial. What means, for example, 4 factorial? 4 factorial is 4 times 3 times 2 times 1. It's 12, 24. It's a multiplication. When you talk about factorial, it's the multiplication of the number, no? Less than 4. This is factorial. Suppose the combinatory number in this equation. Suppose I want to find this 10. This 10 is 5 factorial. Why 5 factorial? Because n is the exponent we're using in the binomial, no? And k, no. K is the order. This is k0, this is k1, and this is k2. Okay, I want to find a specific in the location 2. Entonces sería 2 factorial divided by 5 minus 2 factorial. Something like that. Okay, how we compute that? Well, we compute this calculator, but no, let's do it by hand. It's 5 factorial, 2 factorial, okay, by the way, 2 factorial is 2 times 1, and 3 factorial es, bueno, 3 factorial. Entonces we expand 5 factorial like 5 times 4 times 3 factorial. Divided by 2 because 2 times 1 is 2 times 3 factorial. And 3 factorial cancel out. It's the same number. And 5 times 4 is 20, divided by 2, 10. Wow, I got it. This is the formula. So the formula for the Newton is then, yeah, refined, elegant. A plus B is square. Square, no, to the n power. Because the formula is valid for any power. Is summation from K equals 0 to M of the combinatory number que es n factorial divided by k factorial divided by n minus k factorial, and a que represent the first expression raised to the n minus k multiplication by b to the k. Bang. And this is the formula that Newton discovered when he was 22 years old. Okay, entonces stop here, stop. And next time we are doing the problem of the binomial theorem. And we start review for the package maybe. Semester is almost over, guys. I precise with you when do the test number 4, and that's it. And remember, the final you take if you need to improve. Otherwise, no. So you get A or you get B.